Okay, for these problems, we're actually going to be working a little bit backwards compared to where we were before. In the previous problems, we found the ratio of perimeters or ratio of sides, and then we used that to find the ratio of the areas. Now we're going to find the ratio of the areas and go backwards to find the ratio of the sides. So for this problem, we're given a rectangular baking pan that's 15 inches by 10 inches, and there's a smaller pan that is similar, and the area is 96 square inches. So we want to find the width of the smaller pan. Best thing to do in a problem like this is draw a picture, and luckily we have the picture drawn here. And if you notice, we have the area here and the area here. So what we're going to do is we're going to write the ratio of areas, which is 150 to 96, and if we simplify this, we end up with 25 to 16. Now remember, this is the a squared over b squared, and we want to know the ratio of sides, or the ratio of perimeters. So I'm just going to write that as scale factor, and the scale factor is a to b. If this is the ratio of the areas, we take the square root of 25 and the square root of 16, and that gives us 5 to 4. Now that we know the ratio of the sides, we can take that 5 to 4, and we want to know what this is, what we'll call x, if we know that that's 10. We could do this also for the other side, but we're not going to worry about that. They asked for the width, so we're doing the width. We know it's big to small. This is the bigger one, that's the smaller one, so we say 10 to x here. We cross multiply, we get 5x is equal to 40. Dividing both sides by 5, we get x is equal to 8 inches. Okay? So again, going through this, we know that the area ratio is a squared to b squared. We want to find a to b. So we start off with the area ratio, which is 96 to 150, or 16 to 25. They wrote it the reciprocal of what we did, but that's fine. The square root of each of these would be the ratio of the lengths, or the scale factor. That's 4 to 5. And they know that this is equal to 0.8, so we could multiply this times the original, which is 10 inches. So 0.8 of 10 inches gives us the 8 inches there. Okay, here's another problem. This one's a little bit tricky because if you look, we've got a length here in feet, we've got an area here in square feet, and then we've got another length that's in inches. So what I'm going to do is convert everything to feet first. And also, this is telling us about a perimeter of 24 inches. This is just telling us about one side of the gazebo, and it's an octagon. So to find the full perimeter, we would just have to do 8 times the 8 sides. And that gives us 64 feet. And the perimeter here is 24 feet. So we can write our ratio of perimeters. And we'll do it big to small. So it would be 64, and then 24 inches is the same as 2 feet, so it would be 64 to 2. That becomes 32 to 1. We want to know the ratio of areas. So in this case, we would do 32 squared over 1 squared, and that gives us 1024 to 1. Now that we know the ratio of the areas, we can use that with this area for the bigger one. So we've got 1024 to 1 is equal to 309, and we'll call the area of the smaller one, the model gazebo, we'll call that x. Cross multiplying, we get 1024x is equal to 309. Dividing both sides by 1024, those cancel, and we get that the area of the model gazebo is 309 over 1024 square feet. Unfortunately, they want it to the nearest tenth of a square inch, so we have to do some conversion here. we know that 1 foot is equal to 12 inches. So therefore, if I want 1 square foot, I have to square both sides. So if I get 1 square foot here, that's equal to this squared, which is 144 square inches. Okay? We're going to use that with this to figure out how much that is in square inches. So we've got 309 over 1024, and that's square feet. We're going to multiply that times this conversion factor right here. And since we want feet to cancel out, we have the feet on the bottom, the inches on the top. We know that 144 inches over 1 square feet is what we have. Multiplying that out, we get 309 times 144. That's going to give us 44,496 over 1024. Dividing those two and simplifying it, we get 2,781 over 64. And now we're in square inches in both cases here. Oops. Sorry. And they want to the nearest tenth. So that would give us 43.5 square inches. So we know the area of the smaller model gazebo is 43.5 square inches. We'll go over this again. Again, we know that the floors are similar, so we want to find the ratio of the lengths. We do perimeter of the full-size gazebo over the model. That's 8 times 8, and we're going to have to convert this to feet. So we end up with 64 over 2, which reduces to 32 to 1. We're going to square both top and bottom. Once we know the ratio of the lengths, we square top and bottom to get the area, ratio of areas, and that's going to be equal to these two areas here. We know it's 32 squared over 1 squared, and this is the area of the full-size one, over x, which is the area of the model, which is what we want to know. We're going to do some cross multiplication, and they gave us the decimal answer. I left it as 309 over 1024, but this is feet squared and we want inches squared, so we convert it and we get 43.5 square inches. Okay, and here's another problem. We're given the ratio of the areas. We want to find the ratio of the side lengths, which is the same as the scale factor. So again, ratio of areas is equal to 20 to 36. We're going to simplify this. These are both divisible by 5. That gives, by 4, which gives me 5 over 9. We want to know what the scale factor is, since again this is a squared over b squared. Oops, b squared. And we want to know what a to b is. That's going to be the square root of 5 over the square root of 9, and that gives us square root of 5 over 3. So that's our answer. Cool. And this last problem, I believe. Again, we're dealing with inches versus feet here. So this is going to take a little bit of doing here. Why don't we convert this to feet? Let's see. Yeah, let's convert this to feet. Actually, let me see what they got for an answer. Oh, let's go back. Okay, so they have it in inches. So let's take a look. If we convert everything to inches, we know that the perimeter here is 66 inches. This is 35 feet. So let's convert that to inches. So 35 feet equals, if we multiply this by 12, we get 420 inches. And this is 20 feet. So 20 feet is equal to 240 inches. And if we want to find the perimeter here, it's going to be 2 times 420 plus 2 times 240. So that is 840 plus 480. Oops. And that's going to give us 1320. So we know that the ratio of perimeters is equal to 66 over 1320. Which reduces to 1 to 20. And we want to know the ratio of areas. So the ratio of areas would be 1 squared over 20 squared, which gives us 1 to 400. And finally, we want to know the area of rectangle 1. Let's see. So we can find the area of rectangle 2 by doing, we're going to do it in inches as well. So it would be 840 times, am I doing that right? No, I'm sorry. It would be 420 inches by 240 inches. Okay. And that gives us a big number, 100,800 square inches. So now we've got our 1 to 400, where the bigger one is 100,800, and the smaller one is the one we want to know. So that's going to end up giving us 400x is equal to 100,800. We're going to divide both sides by 400. And we're going to end up with 252 square inches. Okay? Whew, bit of a mess there, but it's okay. So again, here's the ratio of the sides. The ratio of the areas would be 1 squared over 20 squared, and then the area of rectangle 1 would be this. And we're done. Thanks.